All right, so here we go. So this one is actually really similar to the one earlier on the sheet where we had to find the angle of the inclined plane. It's basically just making sure that you know how to derive the acceleration of a thing rolling on a plane. So go, brain, process. The problem actually gives you kind of more information than you need. So anyway, so here we know. So we know we've got this ramp that's 9 meters long. It's 3 meters tall. We know the rotational inertia is 2/3 mr squared, and we're trying to find, what are we trying to find? The acceleration and the force of friction. Okay. And I believe I gave you the mass, didn't I? Oh, hold on. Sorry. Oh, I can just look at my work. Duh. Did I give you the mass? Yes, 2.5 kilograms. Cool. So let's make a note of that. M equals 2.5 kilograms. Okay, so I hope I changed that. Hold on 1 second, you guys. I'm sorry. Whoopsh, whoopsh. There it is, 2.5 kilograms. All right, cool. All right. Anyway, sorry. All right. So we're trying to find out what is the acceleration and what is the force of friction. All right. So again, there's a couple ways of doing this. I really think that because we don't know what our frictional force is, it makes more sense to choose our pivot point at that force of friction and solve it from there. So let's make our free body diagram. So we're going to have FG parallel, which we don't care about because it's not going to produce any torque. We've got FG parallel, which is just mg sine theta. Notice, so I'm guessing most of you probably saw this and immediately found your angle. But notice the sine of this angle is just 3/9, right? Opposite over adjacent, or opposite over hypotenuse. So you can just replace the sine of theta with 3/9, which I think is what I did on my solved problem. Okay. I will solve it though, with the angle because I'm guessing that's probably a little more intuitive to most of you. So if you find the angle, it does turn out to be 19.5 degrees. All right. Let's see. Other forces we have to contend with are the normal force, which is not going to matter because it doesn't produce any torque, and pesky friction. Pesky upgraded from stupid to pesky. All right, so there's our static friction. And because the wheel is not rolling as fast as it possibly could be, that is not our maximum static friction. It's just force of friction. Okay, so I'm going to choose this as my pivot point to negate that unknown force of friction. So what I need to do then is I need to find my rotational inertia about that pivot point. So that's going to be the rotational inertia about the center of mass plus mh squared, where h is just your radius again. So the rotational inertia about our pivot point ends up being 5/3 mr squared. There we go. So now I'm going to write a net torque equals net torque equation. So the net torque oh, this is not number 8 anymore, is it? I think this is number 9. I don't know, whatever. It's numbered right on YouTube. All right, so net torque equals net torque. So let's see. So we've got I, 5/3 mr squared, times alpha, but I want my r's to cancel, so I'm going to replace this with a over r. Also, because I'm looking for a, not alpha. All right, that's got to equal our net torque. And the only force providing a torque is FG parallel. So that's mg sine of theta, which is either sine of 19.5 or 3/9. So there's our force of gravity times r. Okay? So all of the r's and m's cancel. And you get 5/3 a equals g sine theta. All right, so there, what are we trying to do? We know the angle, so we can find our acceleration, right? So a is going to be, what, 3/5 g sine theta? Okay. So there's our acceleration. So if you solve that, you end up getting 1.96 meters per second squared for your acceleration. Okay, let's make a note of that up here. And now we got to find our friction force, which we can do just by doing a net torque equals net torque equation. All right, all of these problems, you guys, all of these problems are just about net force equals net force, net torque equals net torque, okay? I started there with net torque equals net torque. Now I'm moving on to net force equals net force. Here we go, net force equals net force. So mass times acceleration. So 2.5 times my acceleration equals FG parallel, which is 2.5 times 9.8 times the sine of theta. I'm going to cheat and use 3/9, so you can do sine of 19.5 if you want, minus force of friction. And then solve for your friction, and it turns out to be 3.27 newtons. So there you go. Cool. Let's see. Yep, that was, number 8. That was number 8. Cool. All right. Have a good one.